Hello everyone, welcome to our the third tutorial of the playlist the Google Earth Engine for the beginners. So in today's video we will learn how to import the Sentinel data from the data catalog and what are the band combination it has and how we can visualize them, how we can interpret the image and what are all the different band combinations for the visualization of the true color composite and the false color composite. So everything we will see in today's video. So let us start with the importing of the Sentinel 2 data first. So let us search Sentinel 2 in the data catalog. So here you can see the harmonized Sentinel-2 mean surface reflectance mean spectral instrument level 2A and 1C are available. So I will use the 1C dataset. So let us open the dataset. So in the description you can see which are all the sensor it is used, and the dataset availability is from the 2015, and the bands it has are the from B1 to B12. So these are all the bands which are useful to us. So most of the bands are in 10-meter resolution, but they also have the 20-meter for the red edge, as well as 60-meter for the near infrared, not near infrared, short wave infrared resolution. So this is the spatial resolution of the bands. So the image properties, it has the cloud pixel percentage in terms of the uh, units are in percentage, and let us import this data by clicking on the import. So let's rename this image collection as S2 for our convenience, which stands for Sentinel 2. And now let us filter this particular satellite image collection to our convenience. So define a variable image is equal to select our satellite data S2 and filter by bounds. So before filtering by bounds, let us create one region of interest by drawing a rectangle in our map layer. So simply draw like this. Here you can see a geometry is imported, but we have to change its properties by going to settings. Rename the geometry as ROI, which stands for region of geometry, and let it import as a feature collection for our convenience, and add the property whatever, let's say ID 1, and click OK. So okay, so here you can see our region of interest is imported as a feature collection, and uncheck this geometry, and we have our ROI. And now let us filter our satellite data with the boundary. So S2 dot filter bounds is the function which is used for filtering any kind of a satellite data for a particular region. No, this is different from the clipping. We are just filtering to the boundary. So this will select an image or the image collection that is only present in that region. So filter the boundaries to ROI, and let us filter also the date with the function dot filter date. Let us filter to the latest 2024. Month is January and the date is 1 2 2024, uh, June 30. You can give any data, but the data set is available from the 2015, so you can give after 2015. So after filtering the data, let us filter our cloud cover also by using the function filter metadata. And let us go to our collection now and go to image properties. So copy this cloud pixel percentage and paste it in here as a string. And you should also give the arguments such as cloud pixel percentage. It should be less than say 1. So 1 stands for percent, as I have already showed you. This cloud pixel percentage is in form of its units are in percentage, so I'm giving the 1 stands for my image should be consisting of the clouds less than 1%. So after filtering the metadata, let us uh, select the first image out of it, and let us clip to our region of interest. So remember that the filtering to the bounds and clipping to the ROI are the two different things. So now let us print our image and see what our single image consists of. So print image and click on the run. So you can see it's computing. So yeah, you can see our image consisting of the date from 2024 January 1 to from January 1 it is only selected. So you can remove this print function and you can directly add our image to the map.add to the function map.add layer. So we are adding the image and we are leaving the uh, visualization parameters as default and rename it as Sentinel 2 for our convenience. So now run the data. So you can see the image is loading here. So now what you can see is just a blank. You cannot interpret anything in this image. So let us now try to play with the bands. So now first continue with the true color composite with 4, 3, and 2. 4 is the red band. This one is the uh, green and blue band. So you can also stretch the range to 100% instead of giving the custom range and apply. So yeah, we have given the band combinations for the true color composite 432, and let's check the layer and check it for 100%. And here you can see uh, our data set is showing the true color composite, that it is a real world visualization, and whatever the waters are seeming to be in the dark blue color, and these are the agriculture lands, and one in the gray and the brown colors are the barren land, and these are all the built up structures. So all are now in the present their true color composites. So let us change the band combination to some of the false color composites, such as uh, to the color infrared by using the near infrared, the red as well as the uh, green band. So our near infrared band in the Sentinel 2 is B8, and our red band is B4, and our green band is B3. So you can stretch the range to 100% for the enhanced visualization and click on apply. So now you can see all the healthy vegetations are turned into red color. So the color infrared band combination is meant to emphasize the healthy and the unhealthy vegetations. So we are using the B8 near infrared to especially to for good at reflecting the chlorophylls, this near infrared, and that's why the healthy denser vegetations are seem to be in the red color, and here you can see the gray patches are the non-vegetated areas, which are build-up areas, which I have already showed you earlier. So let us try another band visualization or the false color composite, which is called as the shortwave infrared, through the use of shortwave infrared band, that is our B12 band, and our near infrared we are using the B8A. So what's the difference between B8 and B8A is that both are near infrared only. uh, they both lie in the near infrared only, but their range varies, that is their wavelength varies, and we are using B4 red for this last band. So again we are stretching for 100% and apply. So again you can see it is using the swir band, near band, as well as the red band. So it is showing the vegetation in the various shades of green. The darker shades of green are indicating the denser vegetation, and somewhat the brown color are indicating the bare soil as well as the build up areas. So like this we have let us try one more band combination for the false color composite using the uh, swir band only, but we are using the different range of B11, and instead of B8A we are using B8, and instead of red band we are using blue band. So stretch to 100% and apply again. So this particular false composition is mainly used to detect the agriculture lands which are healthy, and to detect the crop's health and monitor the health of a crop. And it uses the SWIR as well as the NIR band, which I have already told you. And both are particularly good at highlighting the dense vegetation. So which are appears the denser dark colors are healthier vegetation, and the light green colors are lower healthy, I mean to say. uh, yeah, that's it. So that's it for today, guys. So if you have any kind of queries, or you want any kind of other videos, please feel to post in the comment section. So thank you for watching.